Hello, risk takers and mathematicians. If you're here, you've attempted lesson 6.5 challenge about equivalent expressions. And so I'd like to show you how we could approach this. So what we needed to do is to determine whether these expressions here were going to be equivalent. And the way we do that is we do some testing and we do some proof. Okay, so we're going to try question 1 first. And the expressions are x times x times x times x divided by x. Whoops, terrible x. Let me try that again. X and x times x times x. So I'm just going to choose the value of 1 right now. I'm going to say that x equals 1. So 1 times 1 times 1 times 1 divided by 1, and 1 times 1 times 1. Okay, 1 times 1 times 1 times 1 is 1 divided by 1. That expression is going to evaluate to 1. And 1 times 1 times 1 is also going to equal 1. So when x equals 1, they are equivalent, but that's not enough. We need to prove that they are always equivalent. So I'm going to choose, let's try x equals to 2. So now we have 2 times 2 times 2 times 2 divided by 2, and 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, and divided by 2 is going to be 8. And 2 times 2 is 4, times 2 is 8. So for x equals 2, they are also going to be equivalent. Now, in fact, these are always going to be equivalent, because if we go to our original expression here, x times x times x times x, and divided by x, these two x's here will actually cancel out, and we'll be left with x times x times x. So we can see that they will always be equivalent. So our next two expressions, we're going to determine if they're equivalent. X plus x plus x plus x divided by x, and x plus x plus x. So I'm going to just, again, choose x equal to 1, and have 1 plus 1 plus 1 plus 1 divided by 1, and 1 plus 1 plus 1. Here we have 1, 2, 3, 4, divided by 1 is 4. 1 plus 1 plus 1 is 3. Already I can tell they're not going to be equivalent. If they're not equivalent for x equal to 1, then they're probably never going to be equivalent. So they are not equivalent. So again, you don't have to be choosing 1 like I'm choosing. You can choose any value for x and y, but you do have to choose the same one. So x and y need to be the same in your little experiments here. So I'm going to say that in this number 3, I'm going to say x is equal to 1 and y is equal to 2. So I'm going to have 2 times 1 plus 2, and then 2 times 1 here, plus 2 times 2. 1 plus 2 is 3. Multiply that by 2, I'm going to get 6. 2 times 1 is 2, plus 2 times 2 is 4. So for when these values are true, then our expressions are equivalent. However, we don't want to stop there. We want to make sure that it works for other values too. Let's try when x equals 3 and y equals 4. 2 times 3 plus 4. And here, 2 times 3 plus 2 times 4. 3 plus 4 is 7. Times 2 is going to be 14. 2 times 3 is 6. Plus 2 times 4 is 8. That's also 14. So these two expressions are equivalent. We could go on and we could try 2 other numbers. However, I can see by the distributive property here that 2x plus y is the same as 2x plus y. And you'll learn a little bit more about that in the upcoming lesson 6.6a. Okay, so for our final one here, 2xy and 2x times 2y. I have chosen x equal to 1 and y equals 2. I'm choosing smaller values just because it's easier to work with. So let's try 2 times 1 times 2, and 2 times 1 times 2 times 2. Okay, 2 times 1 is 2, times 2 is 4. This is going to be 2 times 1 is 2, times 4, that's going to be equal to 8. I'm just going to check again. At the moment when x is 1 and y is 2, they're not equivalent. But let's see if x equals 4 and y equals, I don't know, 6. 2 times 4 times 6, and here we have 2 times 4 multiplied, 2 times 6. 2 times 4 is 8, times 6 is 48, 2 times 4 is 8, times 12, that's 96. Okay, so these are not equivalent. So remember, to determine if expressions are equivalent, you want to first substitute a value for x and y or any of the variables. But remember, if an expression is equivalent, if the two of them are equivalent, they will have the same value for whatever value you determine the variable to be. Okay,